Hello, my name is Balin Armstrong, and my research is on using Colaboratory for partial wave analysis at GlueX. And so what is GlueX? GlueX is an international hadronic physics experiment located at Jefferson Lab, and you can see in the bottom left where Jefferson Lab is located relative to William and Mary. And so at GlueX, a photon is collided with a proton to produce particles which then decay into other particles. The particles that are the result of the decay are then able to be measured, and the initial particles are able to be determined. And so in my research, I was specifically looking at the photon and the proton, creating an omega meson, a pi zero, and proton, where the omega meson would then decay into a pi minus, a pi plus, and a pi zero. A meson is just a type of particle found in physics. And so as I mentioned before, the initial particles are able to be determined. Example of this is with the omega meson, as shown here in this graph, where the omega is able to be determined by this large peak in the center of where we expect the meson's mass to be. And thus we know that this is the reactions that we're looking at, and the rest of this is just noise that we are unconcerned about. And so in my research, I use Colaboratory, which is a Jupyter notebook environment, to fit the data of the omega pi zero proton final state. And then PyRoot was using Colaboratory to plot the fit data and display the graphs in an interactive Python file. And as you can see here, this is an example of what the Colaboratory environment would look like. There's nothing important here, it just gives you an idea of what it would look like though. Originally, high-performance clusters were used to create a direct PDF output by fitting the data to 5 equations, creating a PDF similar to what's shown on the left. However, in my research, I developed a method of displaying the fits in the interactive Python file directly. And by comparing the two, you can see that they are the same. And so these fits be done over multiple ranges of the momentum transfer between the photon and the proton and the mass of the products, creating many different points of data as shown here, where each of these points on the graphs is a fit of the parameter. And so then in partial analysis, by looking at the diagonal shown here and here, a peak in the intensity of it would show that there is a high dependence on that particular equation. And thus, if there is a interesting behavior, such as a shape going like this, it's not present in this graph, but if it was, a shape going like this would indicate that there is some physics going behind it. In conclusion, this research was done in collaboration with an international hadronic physics experiment. I developed a new procedure for amplitude analysis that can be done on a freely available cloud system like Colaboratory. And I presented this research at the American Physical Society Division of Nuclear Physics meeting this past fall. Thank you for listening and your interest in my research.